Okay, so we divided polynomials, we know to factor polynomials, and now we're going to factor using sum or difference of cubes. And it's still factoring a polynomial, but there's no factor theorem, there's no synthetic division, long division. This is just a formula or a concept to follow. Remember from grade 10, difference of squares is kind of the same thing. If you know the formula, you can factor polynomials, whether it's difference of squares, difference of cubes, sum of cubes. So this was difference of squares. It was a squared minus b squared. Some of us confuse perfect square trinomials with difference of squares. Maybe I'll show you that in a sec, but I don't know. And it just equals a minus b times a plus b. It's one of the easiest things to factor because it's just kind of like you memorize it and you're good. For instance, when you have something that is a difference of two squares, now we know this is a difference of two squares because 49x squared is 7x squared, and this is 11 squared. This is why it's a difference of squares, and you can see the squares right here, right? Find the square root of this, find the square root of this, and it's proven that it's the difference of two squares. Now, to get to the answer, I just open up two brackets. This is my a squared and b squared, so a and b. One is plus, one is minus, doesn't matter where the signs go, and I factored using difference of squares. That's it. Okay, pretty straightforward. Now, there was never a sum of squares when you're doing difference of squares because it's impossible to exist. If you think of solving a sum of squares, as soon as I move that 121 over an equal sign to solve, you can see how when I find the square root, it's going to be an imaginary number. It's not allowed, right? So there's no such thing as sum of squares, only difference of squares. Or you can think of it as the parabola is shifted down and faces up, so there's going to be x-intercepts, right? But if it's the other way around, there's not going to be any x-intercepts. Cubes, however, a little different. Cubes are a little different. You could solve for the cubic root of a negative number. Negative 2 times negative 2 times negative 2 is negative 8. Therefore, the cubic root of negative 8 is negative 2.
All grade 9s, please proceed.
So the formula for difference of cubes is just the difference of two cubes. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. You got to start remembering some cubes, especially 2, 3, 4, 5, 6. Memorize them. Just do them on your calculator. Play with your calculator. The formulas are a minus b, and then it's a squared plus ab plus b squared. A lot of mistakes can happen here. This looks like a perfect square trinomial because in a perfect square trinomial, there's a 2 in front of the ab. Okay, and I'll show you how to create them instead of like memorizing a formula, even though you kind of still have to memorize it. Just notice that in the difference of cubes, you start with the difference of the cubic roots, right? Okay, and the sum of cubes is actually a plus b, where you start with. So the signs where you start match the sum and difference. And then, after you've matched those signs, the first sign is always different than this one. So you're starting difference of cubes. This is going to be difference. The first sign you write is definitely not going to be that. Okay, and that's an easy way to remember it because these signs alternate, right? Plus and minus. You might make a mistake. So let's see how this works and link it back to the formula. If I want to factor this expression, you need to know that these are cubes. You need to know that 125 is 5 cubed. You need to know 27x to the 3 is 3x cubed. Just like you did with difference of squares. You don't have to write that step down, but you need to know that it's a cube. And then your first step is going to be opening up brackets. I like to set myself up. I know the cubic roots are going to go here. The sign that goes here is always the sign in the question. So this is a sum of cubes, so that goes there. And then I formulate the rest using these numbers. I do not look up here anymore. I don't want to find the value of a squared from a cubed. It's harder. So if this is a, square it. If this is b, square it. The guy that goes in the middle, just multiply them and put it in the middle. What sign goes there? Not that one. And you're done. Now, a lot of guys who are good at factoring are going to kind of be alerted to this looking like a perfect square trinomial, even though I said it here. Maybe it doesn't make sense over here. 9x squared, 25, lights go off, but the root of this times the root of this, 5 times 3 is 15, doubled, is not 30. This isn't 30, so this is not a perfect square trinomial. Also, you can't factor this, ever. And the reason is because you can't factor this. So when you're doing sum or difference of cubes, stop thinking about factoring the rest. 90% of the time. You're gonna see how I'm wrong over there, but whatever. And that's it, that's how we use the formula. Okay, let's move on to the next one. You're not always gonna have something that stares at you in the face saying I'm a cube, so please don't don't forget, you always need to common factor first. And now I have a cube. What is 448 divided by 7? 64, perfect. And you can now see that I have a difference of cubes. 64 is 4 cubed. So I open up brackets. Notice how I started. I started with the 7x, because this is a 0 through the origin. I'm opening up brackets. X minus 4, I'm matching the sign. The cubic root of x3, the cubic root of 64. And then I open up a trinomial bracket, and I build it using this. X squared, positive 16, multiply them, stick it in the middle, don't use that sign, and I'm done. Sum or difference of cubes should be something that if you see, you're very happy about. You get out quick, it's kind of like a memorization thing, and there's not much mistake you're gonna make, not much error you're gonna make. You're gonna see in your homework where you start including fractions and binomials. Yeah, there's room for error, so practice those so you make a mistake and correct them. But other than that, a cube and a fraction is the same thing. Okay, last one. We have a fat one here. X to the 9 minus 512. Nothing in common. Is x to the 9 a cube? Yeah. X to the 9 is just x to the 3 to the 3. It is a cube. 512, if you don't know if 512 is a cube, you just say the third root, the cubic root, learn how to use that on your calculator, of 512 is 8. So this is 8 to the 3. Okay? And I could also break that down to a 2 to the 3 to the 3, so they look the same. Okay? That might help me speed up and get straight to my answer, but let's just do it this way for now to see where we go. So, it's difference of 2 cubes, so I start by writing down the difference of those cubic roots. I create this one using this. I square the x to the 3, I get x to the 6. I square the 8, I get positive 64. And I multiply the 2, stick it in the middle, and I don't put that sign. And I factored it in one step. Now, I told you not to look here because you can't factor this, but sometimes you can factor this. This is x to the 3 minus 8. This is another difference of cubes. So I have to actually break this one down into another difference of cubes, and this one's just going to follow down because I can't factor this further. So this cubic root is x, cubic root is 2 minus. I already know that these signs are plus plus as soon as I do difference of cubes. X squared goes in the front, 4 goes at the end, and 2x goes in the middle. I look here, I look here, I look here. This cannot be factored anymore. I'm done. This only has one x-intercept. Okay, it's an x to the 9 function, so it looks like this, but it only goes through the x-axis once. Right? So probably x2 goes, I don't know, like this. Right? Completely made it up. I have no idea how this function looks. Right? But all I do know is that it went through positive 2 in the x-axis. Okay, pretty straightforward, sum and difference of cubes.